Hey Kyana, so this one's number 7. They give us a car of a certain mass. It rounds an unbanked curve at a certain speed, and then they give us the radius of the curve. What's the minimum coefficient of friction between the car and the road required so that the car does not skid? Okay, so the first thing I did was I found centripetal force because they gave us mass, velocity, and radius. So I plugged that in. So you square 625 first, and then divide by 72 and hit enter, and then multiply by 25. I guess you don't have to hit enter. I always do. Okay, and that gives you this amount. Okay, they ask us for the coefficient of friction, so that's the formula. Friction equals coefficient times normal force. We can figure out the normal force because in our free body diagram we know that weight pulls us down and the normal force is the exact opposite. That the normal force is why you feel the chair pushing up against your butt whenever you sit down. So the normal force is essentially the weight. So the weight is going to be the mass they gave us times gravity, and that's the number I got. So I plugged that in for the normal force. And then for the force of friction, it's going to be the centripetal force because they said that they wanted to know about if the car didn't skid. So remember every time I scooted a coffee mug against the table and I said there's a certain amount of force of friction that you have to overcome. Well, that's what we're talking about here. The force of friction to overcome is the same as the centripetal force if we're not skidding. So I'm plugging this in here, equals coefficient of friction times the normal force, which was the weight. I divide both sides by this 9074.25, and then that gives me 0.89. And coefficients of friction don't have units.